everyone, welcome back to the channel Kanu Sir, and I'm your teacher Pawan Kanu, and I'm back again with a new topic here, that is HCF and LCM, or you can say highest common factor and least common multiple. And I'm very thankful to the subscriber who has requested this topic there, and he is Rajesh Bania. One of my subscriber has requested in the comment section below in the previous video. So I have discontinued the topic cone, cylinder, sphere, and I will started the next topic, that is HCF and LCM. After this topic I will go back again in a cone, cylinder and pyramids. So as per the request put in the comment, I have started to explain the topic, that is HCF and LCM, and without wasting the time, let us understand what is HCF and LCM. So before understanding the actual topic, let us solve some questions related to HCF LCM. For an example, number 1, let us take the HCF between some number, that is 12, 16 and 18. So there are three different numbers. Here we are going to find the HCF of numbers. So mostly in the lower classes we have done finding the prime factor of these numbers, like 2 times 6 is 12, 2 times 3 is 6, and 3 times 1 is 3. For 16 we will write 2 times 8 is 16, 2 times 4 is 8, 2 times 2 is 4, and 2 times 1 is 2. And for 18 you can do 2 times 9 is 18, 3 times 3 is 9, and 3 times 1 is 3. Finally, you will be writing here 12 equals to 2 times 2 times 3, and 16 is equals to 2 into 2 into 2 into 2. 1 we will not write here because we don't have to use that one, or in most of the cases where we need to use 1, I will explain you. After that, 16 is 18, 2 times 3 into 3. So the meaning of HCF is highest common factor. Here we have found the prime factors of the numbers, and here we have stated the numbers. Now we have to check the number which is common in all the three, because the word is common, highly common factor or highest common factor. Let us check the common factor in all the three, that is 2. After finding one of the common factors, rest of the common factors are not common in all the three numbers, or the three factors of the number. So we can directly write the HCF is 2. What if there used to be 3? What if there will be 3 in 16? Then there will be another highest common factor as 3, but we don't have 3 in 16, so we just write here 2, and this is not the highest common factor. So the factor which is common in all the three numbers will be called as the common factor and the highest common factor. One more example I'll take, 27 and 15. So 3 times 9 is 27, 3 times 3 is 9, 3 times 1, 3 times 5 is 15, and 5 times 1 is 5. So when you write 27 and 15, you will be writing 3 into 3 into 3, and for 15, 3 into 5. Again the here common factor is 3, and hence the highest common factor is 3. One more example, in place of 15 if we put 18, then you will be writing here 3 times 6 is 18, 3 times 2 is 6, and 2 times 1 is 2. Then in place of 15 if you write 18, you will be getting 3 into 3 into 2. It means one more number will get common among these two numbers, they are prime factors. So you will be writing 3 into 3 is 9. So the highest common factor in the numbers from 27 and 18 will get 9. Or in another understanding you can see 9 is a number that can divide both the numbers. So it is called a common factor. 9 times 3 is 27, 9 times 2 is 18. Similarly here 2 can divide all the three numbers, so it is the highest common factor, the number which can easily divide or is able to divide all the given numbers will be called as highest common factor. Now let us go for LCM, that is least common multiple. So for least common multiple, I will not erase this example. Let us take for least common multiple of 16 and 18. We have to find first the multiple of 16, or I will make it easier for you students. Just let us write multiple of 2 and 4. So the multiple of 2, you will be writing 2 times 1 is 2, 2 times 2 is 4, 6, 8, 10, 12, 13, 12, 14, 16 and so on. There is no limit of the multiple of 2. Similarly, for the multiple of 4, you will be writing 4, 8, 12, 16, 20, 24 and so on. Here you can find the common digits 8, 12 and here you will get 24 also. So 24 and also here 4 and 16 also you will get 20. Almost all the numbers in the multiple of 4 are also the numbers in multiple of 2. But the least, the smallest number which is the multiple of both the numbers, that is 4. And common in both the numbers. 4 is the first common multiple for the both number, and hence the least common multiple is 4. So this is the understanding of least common multiple. In the lower classes we have experienced this type of solutions, but in higher classes when we got upgraded, yes, and when we came up in a higher classes, then we changed our concept here about HCF and LCM, and just to find the value we started solving the HCF and LCM in the same manner, in a similar manner. Like if I say to you to find the LCM of these numbers, then very easily you will say first the value of HCF and the remaining other numbers which are not common here. So 3 is not common, 2 is not common, so 3 into 2. So what is the HCF taken out? That is 9 and 3 and 2. So finally 9 times 3 is 27 times 2 is 54. So LCM of 27 and 18 is 54. It means what we have understood about LCM is that there must be a common number that can be divided by 27 and 18 both. So 54 can be divided by 27, like 27 times 2 is 54. Also 54 can be divided by 18, like 18 times 3 is 54. So in another sense of understanding between HCF and LCM is that HCF is a number that can divide the given quotients, and LCM is a number that can be divided by the quotients. HCF will divide the given numbers in a quotient, LCM will be divided by the given numbers in a quotient. So we don't remember this type of solution in a higher classes. We just forget that and we start solving in a similar manner. We find LCF and also in the same point we find the LCM in the same method. But actually you must understand LCM in this term. So one more time I want to explain you that HCF is a number that can divide the numbers given in a quotient, whereas LCM is a number that will be divided by the given quotients, by the given numbers in a quotient. So now let us come in class 9, 10 or 8, or simply you can say 8, 9, 10 questions related HCF and LCM, and before understanding those questions in algebra form, Actually here I am going to explain you the process of HCF and LCM in terms of algebra now. So in algebra, before understanding HCF and LCM, you must be getting the knowledge about the factorizations also. So for that, let us take the formulas that are needed in HCF and LCM. That is a plus b whole square is the formula for a square plus 2ab plus b square. A minus b whole square is the formula for a square minus 2ab plus b square. Again, a square plus b square will have two formulas, a plus b whole square minus 2ab and a minus b whole square plus 2ab. Here you can remember the formula. If you keep plus inside the bracket, then there will be minus outside of the bracket. If there is minus inside the bracket, then there will be plus outside of the bracket in the formula for a square plus b square. And when you take the formula like here plus, then there will be plus in front of 2ab. If you take formula containing minus, then there will be minus in front of 2ab. Similarly, for the cube form a plus b whole cube, the formula is a cube plus 3a square b plus 3ab square plus b cube. Here what are we doing is that the power of a is decreasing, a cube, a square and a and lost. Similarly, the power of b is increasing, there is no b, now there is b square and b cube. For a minus b whole cube, you can use a cube minus 3a square b plus 3ab square minus b cube. So the term change like there is minus plus minus, or minus is in the corners and plus is in the middle. After that, there is another formula a cube plus b cube. I am actually giving the formula that is needed while finding the HCF and LCM of a given expressions. So these are the only formula that are required. So there are some other formulas of a square, b square, a minus b or a cube plus b cube also. But I will be giving just some required important formula that are used for finding the HCF and LCM. So a cube plus b cube has got the formula a plus b, a square minus ab plus b square, and a cube minus b cube will be a minus b, a square plus ab plus b square. It means if there is plus in the smaller term, then there will be minus in front of ab. If there is minus in the smaller term expression, then there will be plus in front of ab. These are the formula that are required for you while solving the question of HCF and LCM related algebra. Now let us take one very common and easy question from algebra, that is a minus b whole square and another is a plus b whole square, and the next is, or let us take just simple one like a square minus b square, and I haven't kept that formula, that is a square minus b square will be a plus b and another is a minus b, the most usable formula in HCF and LCM. So here we will be writing like solution, and this term will be taken as first expression, that is equals to a minus b whole square. Because it is whole square, you can change in the product form like a minus b, a minus b, and here the main aim to find the HCF and LCM is in the term of product form. You don't have to multiply these two variables or expressions again to change in this formula. Actually the questions will be given in this form, in expanded form. You have to find them back to their product form. So this much is for the first expression in HCF and LCM. And now for second expression, that is a square minus b square, and just simply if you know the formula you can open now easily a plus b, a minus B. Therefore, HCF. Now the meaning of HCF while solving from algebra terms, you have to understand the meaning of HCF is the common multiple in both the expressions. So A minus B is seen in both the expressions first. So the HCF is A minus B. What if nothing is common? Like A minus B, here we get A plus B and A plus B. What if nothing is common? Then the HCF will only be 1. If none of the expressions are common, we'll write just 1 is the answer. But here it is different, here it is minus. So the common term is A minus B in the both expressions. Similarly, while finding the LCM, the same understanding of previous topics which I explained here just some minutes ago is that we have to find HCF first, that is A minus B. After finding the HCF, now the remaining terms will be called as the part of the LCM, like one more times A minus B and A plus B. So the meaning of HCF and LCM, or the way of doing HCF and LCM in algebra, is that for HCF you just find the common expression, and in LCM find first common expressions, then put all the remaining expressions which are not common. After this example, let us take one more example. That is A square plus 2AB plus B square, and next is A square minus B square, or you can write A cube minus B cube. Then here you will be taking as a solution plus B cube, okay, minus B cube. Solution, and first expression that is A square plus 2AB plus B square. If you remember the formula, you can directly write A plus B whole square, and after writing that you can change in the multiple form like A plus B into A plus B. Otherwise, you can do the midterm break of the 2AB, and you can do the factorization and finally get the answer. After that, next is second expression equals to A cube minus B cube, and you have to again memorize the same formula which I have noted here, that is A minus B, A square plus AB plus B square. Now you need to find the HCF, and while finding the HCF you must find the common expression in both the expressions. So here we find nothing is common. Here is A plus B, but here is A minus B and A square plus AB plus B square. So now in this condition you just have to write 1 as the HCF. If nothing is common, so the HCF is 1, because we don't write into 1 here in the expressions. But about the LCM, you have to write rest other remaining terms which are not common, that is A plus B, again A plus B, and A minus B, and whole A square plus AB plus B square. So this much for this video here about HCF and LCM. I will be doing some other questions related HCF and LCM from the algebra topic. So if you have some other questions related this topic, then you put your questions in your comment section below. I will be explaining you about those questions also in my next videos if you have their questions in the comments. So don't forget this video to share among your friends and subscribe the channel. And without practicing, you will not understand any of the mathematical questions and problems, and without practicing you will never remember and you will never memorize any of the formulas here. So for that, keep practicing, keep learning. Bye.